Hello children. In this video, we are going to continue with the relationship between zeros and coefficients of a polynomial. So, in the previous video, we had seen if alpha and beta are the zeros of a quadratic polynomial ax square plus bx plus c, where your a is not equal to 0, then we can say that x minus alpha and x minus beta are the factors of p of x. Yes? Also, sum of the zeros, it was what? Sum of the zeros is alpha plus beta. It is minus b by a. That is minus of coefficient of x by coefficient of x square. Similarly, product of the zeros, it is equal to c by a. That is constant term by coefficient of x square. Okay, and we have seen the problems to verify this condition. Okay. Also, if sum of the roots and product of the roots is given, then we can frame a quadratic polynomial. It is written as k into x square minus sum of the roots into x plus product of the roots. Okay. In this video, we are going to see the relationship between our zeros of cubic polynomials. Okay. Now suppose if alpha, beta and gamma, this symbol is called as gamma. Okay. So if alpha, beta and gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then sum of the roots, that means it will be alpha plus beta plus gamma, it is equal to minus b by a. Minus b by a, that means what? It is nothing but minus of coefficient of x square by coefficient of x cube. Okay, sum of roots zeros of your polynomial, it is always what? Minus of coefficient of x square by coefficient of x cube. Okay, next it is what? Sum of product of the roots. That means what? Alpha beta plus beta gamma plus gamma alpha, that is equal to c by a. Now c by a, that is nothing but what? It will be a coefficient of x divided by coefficient of x cube. Okay, and product of the roots, that is alpha into beta into gamma, it is equal to minus d by a. Minus d by a, that means it is minus of a constant term by coefficient of x cube. Clear? So always you have to remember your sum of the roots, product of the roots for quadratic polynomial, as well as for cubic polynomial, sum of the roots, that is sum of the zeros, then product of the zeros, and sum of your combination, it is sum of product of the roots. Okay, is that clear? Now we are going to see the question. Verify that 3 minus 1 and minus 1 by 3 are the zeros of the cubic polynomial p of x. Okay, now we know that I can say your k is a zero of a polynomial p of x when only if my p of k, it is equal to 0. Yes, in the 9th standard we have studied. So I have to check whether 3 is 0 of the cubic polynomial. So what should I check here? I should check whether p of 3 is equal to 0 or not. Similarly, p of minus 1 is 0 or not, and p of minus 1 by 3, if I am getting it as 0, then I can say 3 minus 1 and minus 1 by 3 are zeros of the given polynomial p of x. Okay, so let's start with it. So p of 3, how to calculate? P of 3 means what? Wherever there is x, substitute the value of x as 3. simplify it and see what is the answer. Okay. So here, first what I have done is comparing the given polynomial with your standard cubic polynomial, or we can say the general cubic polynomial. I have the values of a, b, c and d. This I have written so that we can verify the relationship between that zeros. Okay. Now, so to check whether 3 0 of p of x, we have considered p of 3. Substitute here wherever is x, put as your 3. So you'll get the answer as here 0. Similarly, find what is p of minus 1. Well, after substituting, I am getting the answer as 0. And p of minus 3 also, wherever it is x, substitute the value as minus 1 by 3. And hence I am getting it as p of minus 3, it is equal to what? 0. That means, have I got p of 3 as 0, p of minus 1 as 0 and p of minus 1 by 3 as 0. So can we conclude 3 minus 1 and minus 1 by 3 are zeros of that given polynomial. Okay. So this we have verified. Next, what it is, we have to verify the relationship. Okay. So what we should do is, this is the given polynomial. Which are the three roots? 3, minus 1 and minus 1 by 3. So consider 3 as alpha, minus 1 as beta and minus 1 by 3 as what? Gamma. Now what should I consider there? I have to consider, find your alpha plus beta plus gamma. And after finding that, it should be equal to, what is that relation? It should be minus b by a. That is minus of coefficient of x square by coefficient of x cube. Okay. So here I have got alpha plus beta plus gamma, it is equal to 5 by 3. Okay. Now what was my, here I am saying it is minus b by a. What was my b here? B is the coefficient of x square. It is minus 5. And coefficient of x cube is 3. So see whether I have got the same. Yes. Okay. Now same, I have to check for alpha beta plus gamma, gamma beta plus gamma into alpha. So I am getting it as minus 11 by 3. Okay. Here you should do what? This is alpha, this is beta. This is beta, this is gamma. This is gamma, this is alpha. Just I have substituted the values. Simplify, you will get the answer as minus 11 by 3. And if you check, it is same as your c by a. That means it is coefficient of x by coefficient of x cube. Okay. Next, product of the zeros. Find the product. You are getting the answer as 1. Okay, this is my product. But what was my d? D, it is nothing but minus 3. Okay, if you check the polynomial, you will get d as minus 3. And what was the value of a? It was equal to 3. So, can I write 1 as minus of minus 3 by 3? Or if you just find this alpha, beta, gamma as 1, then consider minus d by a. Okay, so minus d by a, it will be what? Minus of d is my minus 3 and a is 3. Okay, so in this case, I'll get the answer as 1 and hence I can say this is equal to minus d by a. I have not considered this. I have done what? I have just rearranged it to get minus d by a. Any method you can use. Okay. Hope this is clear. So can I say that everything it is verified, that relationship between the zeros and coefficient is verified? Yes. Now, see the next is division algorithm for the polynomials. Now in the previous chapter we have seen what division algorithm or Euclid's algorithm have we seen? Yes? Or for in ninth standard, have you studied division algorithm for a polynomial? That is nothing but what we usually do. In lower classes, we have seen what it was. If I have a dividend, I have a divisor, quotient. If I'm going to divide a dividend by divisor, then I will get some quotient and the remainder. Always, what is the condition on remainder? Your remainder either it is equal to 0 or remainder is always less than your divisor. That is in general for the numbers. Now here we are going to see for the polynomials. Okay, so if p of x and g of x are any two polynomials with g of x not equal to 0, then we can find polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x. This is dividend, divisor, quotient and the remainder. Okay, now see what is the condition on R. Your condition on R, it is what? Your condition on R of x either is 0, that means the remainder may be 0. Now here R of x is nothing but a polynomial. So either it may be a 0 polynomial or degree of R of x. Okay, it should be less than degree of g of x. That means if I have g of x as x cube plus 1, okay, x cube plus 1, that means in that case my degree of r of x will be either 2, either 1, or it may be equal to what? 0. That means it will be a 0 polynomial. Understood? Is that clear? So this is the division algorithm for the polynomials. Now, what we will do is, the question is, divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square. Okay. Now, what we should do is, first, rearrange the given polynomials in a descending order of your according to the degree. So what can I write here? It will be my, for this I have to divide this by this. So whether this is my which polynomial? It is a dividend. So may I write dividend, that is here p of x. I can write the degree in descending order. So minus x cube plus 3x square minus 3x plus 5. Similarly, g of x as, it will be what? Descending, minus x square plus x minus 1. Okay. So here I have written your dividend as well as your divisor. Now usual your division method we have seen in the 9th standard, how to divide two polynomials. Okay. So I have written this dividend here, dividend here, and this is my divisor. Now see, what is the degree of this, or what is the power for x here? In this case, is it 3? Here, is it 2? Okay. Now, x square into what will I get as x cube? Yes. If I multiply x square with x, will I get as x cube? Yes. Because what is the law? A raised to m into a raised to n is a raised to m plus n. Okay. So x square should be multiplied with what? It should be multiplied with x. Okay. Now see the sign. Now here it is minus x square. I need it as minus x cube. So it should be multiplied with what? Whether should I multiply with minus x or should I multiply with x? it should be multiplied with what? It should be multiplied with x, because if I multiply with minus x into minus x square, it becomes what? Plus x square. But what is here? It is minus x cube. Sorry, minus x into minus x square, you'll get plus x cube. Okay, so plus x cube I don't need. I need it as what? Minus x cube. So it should be multiplied with positive x. Okay, now what to do is, this x should be multiplied with each term here. So it is minus x cube plus x into x is x square, and this here you will get as minus x. Clear? Now what is the next step? Suppose if I want to divide 5 by 3, what do you do? Here 3 ones are 3. After this, what you do? Here do we give here minus sign? That means I am subtracting this 5 minus 3. Okay? That means whenever you are dividing, you are just changing the sign. I am writing here minus. When I write minus and bracket is here, that means I have to change the sign inside. Okay, so I have to just change the sign. Don't forget to change the sign. So minus becomes plus, plus becomes minus, minus becomes plus. And then according to the new sign, do the operation. So this and this will get cancelled. 3x square minus x square, you will get 2x square. Then minus 3x plus x, it will be what? Minus 2x, and then plus 5 as it is. Okay, I have changed the sign and I will get this. Okay, now see what is the degree of this polynomial. Degree is 2. Here degree is what? 2. That means again I can divide it. Okay, now minus x square into what will I get? 2x square. Yes, what will I get? I'll be getting as what? It will be my, yes, minus 2. Okay, or what you can do is, this here is 2x square. So 2x square divide by what is here? Minus x square. So x square will get cancelled. What is the remaining? Minus 2. So that minus 2 should be written at here. Okay. So I'll be getting as minus 2 into, multiply minus 2 with each term. So minus minus becomes plus. So plus 2x square minus 2x plus 2. Change the sign. Then that first terms will get cancelled. This also will get cancelled. And the remainder I'll get as 3. Now check what is the degree of this 3. Is it a constant polynomial? Yes. Now this is a constant polynomial. So what is the degree? It will be equal to what? It will be 0. So degree of this polynomial is 0. Here the degree is equal to 2. So whether degree of your remainder is less than degree of this. Okay. And that will be our last one. That is the last procedure. What we have to, so we have to stop it here. Okay, and hence we have got quotient is x minus 2 and remainder is 3. Again what we have to do is, we have to verify the division algorithm. Okay, so what was the division algorithm? It was divisor into quotient plus remainder, that should be equal to your dividend. Okay, in this case I have this as a quotient, this as a remainder. So substitute the values. Yes, simplify it, then you will get the answer as minus x cube. Okay, minus x cube plus 3x square minus 3x plus 5. If you check, it is same as your dividend. Hence we have verified division algorithm. Hope this is clear. Okay, we'll stop in this video. We'll continue with the next video.